All right, buckle up, everybody, because today we're going deep on a high school science project.
Oh, this is going to be good.
Yeah, but not just any project. This was called Space Balloon, and it was done by students all the way over in Germany at Bodensee-Gymnasium, Lindau.
Ambitious.
You can say that again. These kids, they set out to send a balloon 30,000 meters up to the stratosphere.
Stratosphere, yeah. I mean, that's where the ozone layer is, right?
Exactly, and they wanted to broadcast the whole thing live on YouTube with video and sensor readings.
That's impressive.
Yeah, and they didn't stop there. They even wanted to see how certain chemical reactions would play out up in the stratosphere.
No, that's thinking outside the box.
Right, like most high school science projects involve, baking soda volcanoes, not launching experiments into near space.
So true. So how'd they actually pull this off? Like, where do you even begin with something like that?
Well, luckily for us, these students, they documented the whole thing. I mean, we're talking thousands of hours of work, CAD models, source code, the whole shebang.
That's dedication.
Right. And they managed to raise over 5,000 euro from sponsors to make this happen.
Wow. I mean, that's a shoestring budget for a project of this scale, even for professionals.
Leading this team is Marco Barasansky.
Okay.
And he's got Nicholas Bayer handling software and flight direction.
Uh-huh.
And then they have Valentin Sutter, their hardware and tech lead.
A real dream team.
They actually call themselves that, a dream team.
That's great. That's how it should be.
Built on trust and support, and you can see that in their work.
Yeah, that foundation of trust is so important for any complex project, especially with so many moving parts like this one.
Right. So let's talk about that project. At the heart of it all is their space capsule.
Oh,
And get this, they used a Raspberry Pi to control everything.
a Raspberry Pi. That's pretty cool. They're becoming so popular for projects like this.
Yeah, they're amazing little computers.
Yeah.
So versatile.
Uh-huh. Pack a lot of power into such a small package.
And this team really took advantage of that. They packed their capsule with so many sensors.
I bet. What kind?
Well, they had cameras, of course, to capture the
Right,
view.
of course. Gotta have this stunning Earth shot.
Exactly. But also to gather scientific data.
Makes sense.
And, having those visuals is so important for any project like this.
Definitely. It helps people connect with the science on a deeper level.
Right. But it's the other sensors that I find really fascinating. They had sensors to analyze the air at different altitudes.
Oh, wow. What were they measuring?
Things like UV intensity, methane levels, CO2, even VOCs.
VOCs.
Those are volatile organic compounds. They can affect air quality.
Ah, right. So they were basically tracking how these elements change as the capsule climbed higher.
Exactly.
That's amazing. That data could be incredibly valuable for environmental research.
Yeah, really useful stuff. And there's more. They also included climate sensors.
Oh, really?
Yeah, to measure things like pressure, temperature, and humidity.
That's a lot of data. What were they doing with all that information?
Well, it helped them understand the atmospheric conditions, of course, but they actually used it to calculate the capsule's altitude, too.
Clever. Using multiple data points to confirm each other, that's smart.
And then they even included a magnetometer.
A magnetometer, what's that?
It measures magnetic fields.
Oh, interesting. I wonder what they were hoping to find up there.
I know, right? Adds a bit of mystery.
It does. The Earth's magnetic field isn't uniform, right?
Yeah, it could be influenced by things like solar activity.
Maybe they were looking for variations or anomalies as they went higher.
Could be. And to top it all off, they even threw in a thermal camera.
A thermal camera. Now that's cool. Everyone loves thermal imaging.
I know. It's like having a superpower, seeing the world in a whole new way.
It is. From that high up, I bet they got some fascinating thermal data.
Yeah. But think about it.
Hi.
Launching a capsule that high above the Earth, how do you even stay in touch with it?
Good point. Communication is key in any space mission.
Right. So they had to figure out how to communicate with their capsule, how to track it, and how to get all that data back down to Earth.
That sounds challenging.
It was. They came up with a pretty ingenious solution, a dual communication system.
Oh, interesting. What did that involve?
So for close-range communication, while the balloon was still relatively low, they used Wi-Fi.
Wi-Fi. Makes sense for that initial phase. It's easy to set up and has high bandwidth. But as it climbs higher, you'd need something more powerful, right?
Okay. For long-range tracking and data transmission, they use something called APRS.
APRS.
Yeah, it stands for Automatic Packet Reporting System.
Never heard of that. Tell me more.
It's a popular choice for high-altitude ballooning because it uses a network of ground stations to relay data.
So they didn't need to rely on expensive satellite links.
Nope.
That's brilliant. Using amateur radio operators around the world, that's really clever.
And to make sure they didn't lose their capsule, They built in some redundancy.
Redundancy?
Yep, a four-fold tracking system.
Wow. They really were taking this seriously.
They weren't taking any chances. That kind of redundancy is a hallmark of good engineering.
It really speaks to their professionalism, especially for a student project.
And it adds to their credibility. But like you can imagine, building something this complex, it doesn't just, come together overnight.
I'd imagine there were a few hiccups along the way.
Definitely. They had to get creative,
Yeah.
solve some tricky engineering problems.
Like what kind of problems are we talking about?
Well, for one, the USB bandwidth on the Raspberry Pi 5, that was their main computer, it was a bottleneck for all the cameras they wanted to use.
Yeah, that's a common issue with the Pi. It's a powerful little machine, but those USB ports can be finicky. What else did they run into?
Well, here's a curveball. They discovered the Raspberry Pi 5 didn't have hardware encoding capabilities.
No hardware encoding.
They ended up having to modify a DC-DC converter to ensure stable power to the Pi.
Talk about resourceful. These kids were thinking on their feet. And what about the ground station? Did they have like NASA-level equipment down there?
Not quite NASA, but pretty impressive. They actually managed to set up a parabolic dish for long-range Wi-Fi.
Wow, a parabolic dish. That's serious business.
Right. And then for backup tracking, they used an APRS antenna.
And they were running all of this from, what, their school computers?
Yep, transformed their classroom into mission control.
These students thought of everything. I'm impressed.
So we've got ambitious goals, a tricked-out payload, a MacGyver-level ground station, and a communication system that could rival a small country. But remember how I said launch day didn't go exactly as planned?
Oh, yeah, the big twist. What happened? Did the balloon just float away?
Well, it was more of a sudden drop than a float away. Let's just say the tether, it didn't hold.
Wait, the tether snapped.
And their sonde took an unexpected plunge. So, did it survive the fall?
Yeah, surprisingly it did. I mean, it wasn't pretty. There was a broken wing and all, but the sonde itself held up.
That's good to hear. At least their hard work building it didn't completely go to waste. What about the data? Did they manage to salvage anything from that short flight?
Well, they got some altitude readings, enough to confirm it reached about 20 meters before, things went south.
20 meters. Not quite the 30,000 they were aiming for. But hey, data's data, right? Especially when you're trying to figure out what went wrong.
Exactly. And speaking of figuring things out, this incident actually confirmed one of their suspicions from earlier testing.
Oh, yeah? What's that?
Remember those funk tests they were doing where they were testing their Wi-Fi range and all?
Yeah, they were pushing the limits of their setup, seeing how far they could transmit data.
Right. Well, they noticed back then that having a bunch of devices connected to the Wi-Fi network caused some issues, but launch day really drove the point home.
Interesting. But didn't they say the signal strength was good on launch day?
Yeah, the signal was strong, no doubt about that. But it turns out signal strength isn't the whole story. The sheer number of mobile devices present, everyone in the audience with their phones and whatnot, that created enough interference to mess with the data transmission.
Wow, so even with a strong Wi-Fi signal, you could still run into problems. That's a good lesson for anyone working on projects like this.
Definitely. You got to consider those external factors, especially in a crowded environment. But mobile phones weren't the only communication hiccup they discovered. They also found some issues with their walkie-talkie system when they reviewed the logs.
Ah, the good old walkie-talkies. You'd think those would be the least of their worries.
You'd think so, right? But clear communication between ground teams is crucial, especially during those critical moments like launch and recovery.
Makes sense. Do you think the delay on launch day contributed to these communication problems?
It's possible. Remember, they had to push back the launch by an hour, which can throw things off, especially when you're working with a tight schedule and everyone's already a bit on edge.
Yeah, even small delays can have ripple effects. Okay, so communication was a bit of a mixed bag. What about the live stream? Did that work as planned?
The live stream itself actually functioned pretty well, considering everything else that was going on. They were able to switch between different camera feeds using OBS Studio.
Okay, so the tech worked. But I remember from their documentation, they weren't completely happy with the live stream. What needed improvement?
Well, for one, the image quality wasn't always the best, probably due to that interference we were talking about earlier.
Ah, right. Anything else?
Yeah, they realized they could benefit from using more tripods and gimbals, to get smoother footage, especially for the ground crew running around.
Right, those shaky camera shots can be distracting. What about that interactive stream mask they were planning? Did they get that working?
The mask itself, yeah, it worked. It was hosted on Stream Elements,
Hmm.
but controlling it with their custom console, that wasn't as smooth as they'd hoped.
So more of a work in progress then.
Exactly. They acknowledged that it just needed more practice and fine-tuning.
It sounds like they had a lot on their plates that day. I mean, with the live stream, the communication, the launch itself, it's no wonder a few things slipped through the cracks.
Yeah, but here's the thing. Despite this setback, they're not giving up. They're determined to launch again.
That's amazing. Most people would be discouraged after something like this, but they're using it as fuel for the next attempt.
It's that scientific mindset, you know? Analyze the data, identify areas for improvement, and try again. And they're not keeping their findings to themselves either.
Right. They're making everything public. The CAD models, code, documentation, it's all up on their website and GitHub.
Total transparency. You don't see that often, even with professional projects. It's inspiring, really. They're inviting the world to learn alongside them.
Yeah, they're pushing the boundaries of science and education at the same time. It's really remarkable.
So where do they go from here? Back to the drawing board? Or are they just refining their existing systems?
Well, from what I've gathered from their documentation, they seem confident in their core technology. They're focusing on refining procedures, mitigating those risks we've been talking about, and of course, improving communication. So basically, they're taking all those hard-earned lessons and applying them to the next launch.
Exactly. And you know what? I have a feeling their next attempt is going to be even more impressive than the first.
It's funny, after hearing about this project, this whole journey they went through, I'm actually more excited about their future launches than I am, like, bummed out about this first one.
Oh, yeah, absolutely. I mean, it's like they've cleared the biggest hurdle, right? They've got the experience now. They know what works, what needs tweaking, and what to watch out for.
Exactly. And they're not letting this setback define them. They didn't just pack up and go home. They dug into the data, analyzed everything, and figured out how to make it better next time.
That's the beauty of science, right? Always iterating, always improving.
And remember, they documented the whole thing.
You mean how they put all their work out there in the open?
Exactly. The CAD models, the code, the documentation, it's all there on their website and on GitHub.
Yeah, talk about transparency. You don't see that often, even with professional research projects.
It's like they're not just pushing the boundaries of science. They're inviting everyone to come along for the ride, to
Yeah.
learn and explore with them.
It's pretty inspiring, actually. It could really encourage more young people to get involved in STEM,
Yeah.
to see what's possible when you combine passion with, a little bit of ingenuity.
So what's the big takeaway here? What does this whole space balloon project, what does it tell us about the power of hands-on STEM education?
Well, I think it's a perfect example of what can happen when you give students the freedom to tackle real-world challenges, They got to experience the entire process, from coming up with the idea to designing and building it to raising funds and then actually launching the thing.
And troubleshooting when things go wrong, which inevitably happens.
Exactly. And the fact that they're not giving up after this setback, that's a lesson that goes way beyond the classroom, That's a valuable life skill.
I bet this experience has sparked a passion for STEM that'll stay with them for years to come.
Oh, absolutely. Who knows? Maybe we'll see some of these students leading groundbreaking research projects someday, all thanks to their early adventures with this space balloon.
Yeah, that wouldn't surprise me one bit. Well, this deep dive has been a real eye-opener. We've seen ambition, collaboration, resilience, all wrapped up in a project that, on the surface might seem like just another high school science fair entry.
It's a good reminder that there's always more to these projects than meets the eye. There's passion, there's ingenuity, and there's a whole lot of learning happening behind the scenes.
And sometimes those are the stories that are the most important to tell.
Absolutely. If anyone out there is feeling inspired by what they've heard today, I highly encourage you to check out the Space Balloon Team's website and all their documentation.
Yeah, you might just find yourself launching into your own, incredible journey of discovery.
And as the team said themselves, and I love this quote, they said, "In everyday life, we're used to things simply working. But when you develop such things yourself, you only then understand how much effort goes into making something plug and play."
Wise words from some very bright young minds.